Good morning, friends. Today's topic is AC with inductor. I'm going to connect the inductor along an AC circuit. So let VL be the potential drop across the inductor L. So this is the circuit which I have drawn. The first equation remains same for everything. Therefore, it is V equal to Vm sin omega t. That is the voltage equation. It remains same. Whereas the second equation alone changes. So since we are using the inductor, we are using the formula from Faraday's laws, that is E is equal to L into di by dt. The negative sign indicates the consequence of Lenz's law, that is it is opposing, the EMF is opposing the cause. That is why the negative sign is mentioned. By applying the Kirchhoff's loop rule, we can take it as V plus E, that is V is the voltage and E is the EMF generated equal to 0. So that is what we are getting from Kirchhoff's loop rule. So therefore, when I am using the expression Vm sin omega t equals L into di by dt. So that is the expression which we got. The next thing is, we are going to separate di separately. So L into di by dt equals. Now we can see here that particular component Vm sin omega t. Now I am going to rearrange it. Therefore, di equals V by L into sin omega t. I am breaking the expression. Therefore, now to find I means it is nothing but integral over di, which is nothing but integral over, so Vm by L is constant, so integral over sin omega t into dt. So I is equal to Vm by L. Sin omega t is nothing but minus cos omega t by omega within the limits. When you are applying 0 to 2 pi or something, we will be using it. So here it is Vm by L by omega, that is Vm by L omega minus cos omega t. I am going to find out the equivalent expression for cos omega t because the first equation is in sin omega t. Therefore, I have to find the expression in the same format. So that is why, so minus cos omega t, I have to write it in terms of sin omega t. Therefore, cos theta is equal to sin of, that is sin 90 plus theta. We can take it over. So theta plus 90 or 90 plus theta. So theta I take it as omega t and 90 as pi by 2. So cos omega t can be taken as sin omega t plus pi by 2. So minus cos omega t is nothing but sin omega t minus pi by 2. So that is what we are using it. So minus cos omega t is equal to sin omega t minus pi by 2. So cos omega t is equal to sin omega t plus pi by 2. So here I am going to substitute it. So sin omega t plus pi by 2 is cos. So for negative is, I am using the expression. So minus cos omega t is equal to sin omega t minus pi by 2 is the expression. Now in terms, I am going to substitute the expression here. Therefore, I becomes, I is equal to Vm by L, that is omega L, which is nothing but into sin omega t minus pi by 2. So that is the expression for I. So I am going to substitute in the terms of Ohm's law. I is equal to V by R. So Vm by omega L. So Vm by omega L, I take it as XL. That is what we call it as Im, where XL is called as the inductive reactance. So it is same as resistance. So the unit will be ohms. So the same unit it will be having as the resistance. So inductive reactance, we call it as inductive reactance. So now we are using the expression, we got XL is equal to omega L, where omega is called as the angular frequency. So angular velocity omega. So angular frequency will be 2 pi nu, like that we will be substituting it. Therefore V is equal to Vm sine omega t. I take it as another expression, the first equation. Therefore the current expression I got it as, the current expression from this I take it as I is equal to Im sine of omega t minus pi by 2. So you will see that I brought it in the same expression. Now when I am looking into it, we will see that the current curve is lagging the voltage curve by a phase of pi by 2. That's what I am going to tell. Therefore voltage leads current by pi by 2, or current lags voltage by pi by 2. So this is the expression we are doing it. So we can, from this expression we can conclude that voltage leads current by pi by 2. Now we are going to draw the phasor, so which is important. The phasor diagram we are going to use it. So whenever you are drawing the phasor, you should be careful because it is nothing but the vector notation. So I am going to separate for AC and DC. XL is equal to omega L. So for AC, frequency changes from 1, 2, etc. It is 2 pi f or frequency. Therefore nu changes as 1, 2, 3, etc. Like that it changes. Whereas for DC the frequency is taken as 0. The frequency is taken as 0. So when I am substituting the expression, you will see that therefore when mu is equal to 1, the frequency is equal to 1, we will get it as x is equal to 2 pi L. When you type at 2, we get it as x is equal to 4 pi L. So when you see that as the frequency increases, the inductive reactance also increase. That is the first part. As the frequency increases, the inductive reactance also increases. Therefore when I am substituting for DC, it is omega becomes 0, XL equal to 0. So we can tell that the inductor offers 0 resistance for DC to pass through. So that is the expression. So we can say that the inductor coil does not offer any resistance for the DC current to flow through it. That's what we got it from the expression. So this is the first case. The next one we will be going with the phasor. So the phasor diagram, make sure that whenever you are drawing the phasor diagram, draw it from the curve, not from the phasor, that is not from the vector notation. Always draw it from the curve. So this makes the curve, this makes the diagram to look neat and tidy. Otherwise you will see that it will not be that much good. So first I drew the curve. First I draw the curve. So here the voltage curve, there is no change in it. So in the same format I draw the voltage curve also. The voltage curve I drew it. Next comes the current curve. When I am drawing the current curve, it tells that the current is lagging the voltage by a phase shift of pi by 2. So it tells that it is lagging. So we should be careful with. So voltage leads by pi by 2. So that is the condition. So when I am drawing the phasor, you should be careful with it. So lagging, that is, it should be starting from negative maximum, reach 0. The curve must be starting from negative maximum, reach 0. It should not be the curve equal to voltage, it should be lesser than that. So you will see that it will be lesser than that. So from negative maximum, the curve reaches 0, then to the positive maximum, same, the 70.7%, from there only the phasor has to be drawn. So please be careful. Only from 70.7% the phasor has to be drawn, both for the voltage as well as for the current curve. So from there I drew the dotted line. So first you can draw the voltage curve. So just you draw the phasor, just rotating with an angle omega. So omega theta is equal to omega t, angular frequency becomes omega. So the rotation we are mentioning it up, that is OA. Whereas when I am drawing about the curve, now it has to be exactly 90 degrees. So from the origin you have to draw the curve exactly at 90 degrees to the, it should be almost exactly 90. You should draw it 90 degrees. So it is coming as obtuse. So make sure that you are drawing it as 90 degrees. So please be, when you are drawing the curve, please be careful. So the angle must between the voltage and the current curve must be exactly 90 degrees. So that part you should be keep in your mind very clearly. So this is how the phasor has to be drawn. So now you will be careful how to draw the phasor diagram. So draw it from the curve, not from the phasor. So if you draw from the curve, it will be easier. So this part will be I equal to Im sin omega t, whereas the entire curve can be taken as V is equal to Im sin omega t. So this is the end of it. You can see into it. So please be careful, especially when you are drawing the curve. You should be drawing it very clearly. So start from the curve, not from the phasor. That is the important thing you have to keep in your mind, especially when you are drawing it. Thank you.